You are worried about time, not a little worried. Worried the way only someone who has watched enough of it disappear actually worries. The way you worry when you catch your reflection in a window and don't recognize the face looking back at you. When a year ends and you can't remember where it went. When someone you loved is no longer here, and the world just kept moving anyway, indifferent and unchanged. I am not here to tell you that doesn't matter. I am here to tell you something else entirely. The question you've been sitting with, the one about meaning, about whether any of this counts for anything in a universe this large. That question isn't a sign that you're getting older. That question is a sign that you are waking up. Physics has been trying to tell you something for years. Nobody translated it into plain language. Tonight, that changes. We are going to start at the beginning of everything. We are going to travel through 13.8 billion years of a universe that did not ask to exist and does not know it does. We are going to arrive at the end at the only question that has ever actually mattered. Not how big is the universe, not how old. Those are the easy questions. The hard question, the one physics can almost answer but can't quite, is this. In 13.8 billion years of matter doing what matter does, what are you, and why does it feel like something to be you? If you are someone who has arrived at the age where philosophical questions are no longer abstract, where mortality is not a concept but a daily companion, this channel exists for you. Not to give you answers, to give you a language for what you already feel. Subscribe and turn on notifications, not to be informed about the universe, but to be changed by it. Now, let's go back to before there was a before, to the moment when even the word moment didn't exist yet. Try to imagine a room with nothing in it. No furniture, no air, no light, no walls, no floor, no ceiling. Nothing. Good. Now remove the room. Remove the space the room occupied. Remove the emptiness itself. Remove the nothing you were imagining, because even nothing is a location, and there are no locations. Remove time. Not the present, not the past, not the future. Remove the very concept of sequence, of before and after. You cannot do this. Your brain physically cannot construct this image because your brain is made of matter that exists in time and space, and it cannot visualize the absence of those things any more than an eye can see itself seeing. That is the state the universe originated from. Not from darkness, darkness is space. Not from silence, silence is time. From a condition that human language has no word for, because every word in every language was invented by creatures living inside time and space after the fact. 13.787 billion years ago. The age of the universe, according to the Planck mission's measurements, give or take 20 million years. Space, time, matter, and energy came into being simultaneously, not in a location, not at a moment. Location and moment came with them. The Big Bang was not an explosion in space. It was an explosion of space. Space did not exist and then began to expand. Not into anything, not from anything. It simply began. In the first second, the universe was 10 billion degrees Celsius, so hot that even the most basic particles of matter, the quarks and gluons, couldn't form stable structures. The universe was pure energy, screaming. In the first 3 minutes, less time than it takes to brew a pot of coffee, the universe cooled enough for protons and neutrons to form. And in those 3 minutes, in that single window that would never come again, all the hydrogen and nearly all the helium in the entire universe was created. Here is where the abstract becomes intimate. The hydrogen in your body, in your blood, in every cell, in the water you drank this morning, was created in those 3 minutes. Not in a star, not on Earth, in the first 3 minutes of time itself. That hydrogen is 13.8 billion years old. It is the oldest thing in you. It is older than every star that has ever burned. For the next 380,000 years after the Big Bang, the universe was opaque, thick as milk, photons unable to travel more than a few meters before colliding with free-floating electrons. The entire universe was a dense, glowing fog of plasma and light, churning without form. And then, at 380,000 years, the universe cooled to around 3,000 degrees. Electrons slowed enough to be captured by protons. The first atoms, hydrogen, formed. And in the moment they formed, light was freed. Suddenly, photons could travel across space. The fog lifted. The universe became transparent for the first time. That light, the first light the universe ever released, the photon flash of that single moment, is still traveling. It reaches us today, outstretched by 13.8 billion years of cosmic expansion into microwaves, washing over every corner of the observable universe as a faint, uniform glow at -270 degrees Celsius. We call it the cosmic microwave background. And here is the detail I want you to sit with. The last time you turned on an old analog television and saw the static, the snow on the screen, approximately 1% of that noise was photons from the CMB ancient light. The echo of the moment the universe first became visible, playing silently in your living room. The universe's first sound. And you have been living in it your entire life without knowing. In 1964, two engineers at Bell Labs in New Jersey, Arno Penzias and Robert Wilson, were calibrating a radio antenna and kept picking up an inexplicable background hiss from every direction of the sky. They thought it was equipment noise. They thought it was interference. They cleaned pigeon droppings off the antenna. The hiss remained. They were hearing the Big Bang. They didn't know. They won the Nobel Prize 14 years later. This is what physics does to people who aren't looking for it. It finds them. After the light was freed, the universe entered what astronomers call the cosmic dark ages, a period of roughly 180 million years in which there were no stars, no galaxies, no light sources of any kind, just hydrogen gas slowly drifting in the dark, pulled by gravity in ways so gradual they were nearly imperceptible. Nothing happening, everything preparing. And then something in the dark began to fall. 180 million years after the Big Bang. The universe is dark and cold and vast. Hydrogen drifts in long filaments through the expanding space, pulled by the invisible architecture of dark matter into structures that won't have names for billions of years. Gravity does not hurry. It has nothing to hurry toward. Over millions of years, the hydrogen begins to gather. It simply pulls, relentlessly, patiently, across distances that make the word large sound almost comical. Clouds condense. The cores of those clouds grow denser, denser, hotter, and then, at the exact center of a gas cloud that has been gathering itself for tens of millions of years, in a moment that has no audience, in a corner of the universe with no name, the temperature reaches 10 million degrees. Hydrogen fuses into helium. Energy bursts outward. The first star lights up. No one saw it. No one recorded it. Or it blazed in perfect solitude for a few million years. Ferociously hot, enormous, burning its fuel recklessly the way only the young and the doomed can. And then it died. But here is what matters about that death. When those early stars exhausted their hydrogen and collapsed, they scattered everything they had built into space. Not just hydrogen and helium, but heavier atoms, forged in their cores under pressures and temperatures that cannot be replicated anywhere else in the universe. Carbon, oxygen, nitrogen, silicon. The universe had learned to make new things. Now I want to tell you something about the body you are sitting in right now. Roughly 99% of the mass of the human body is made up of 6 elements: oxygen, carbon, hydrogen, nitrogen, calcium, and phosphorus. Not 7, not 12, 6. And here is the origin story of each one. Hydrogen, 9.5% of your body by number of atoms, was created in the first 3 minutes after the Big Bang. It has existed for 13.8 billion years. The hydrogen atoms bonded in the water molecules in your cells today are older than the Earth by nearly 10 billion years. Carbon, 18.5% of your body by mass, the scaffolding of every organic molecule you are made of, the substance of your DNA, was forged in the nuclear furnaces of dying stars through a reaction called the triple alpha process, where 3 helium nuclei fuse into 1 carbon nucleus at temperatures of 100 million degrees. The carbon in your body passed through at least 1 stellar death before arriving here. Oxygen, 65% of your body by mass, the element you are mostly made of, and the one you require with every breath, was produced inside massive stars and ejected into space when they went supernova. Every breath you take is a celestial inheritance. Calcium, your bones, your teeth, the structural architecture that holds you upright, was produced in a type of supernova called a Type 1a, when a white dwarf star steals mass from a companion star until it crosses the Chandrasekhar limit and detonates. Your skeleton was built from the debris of a stellar suicide. Iron, the element in your hemoglobin that makes your blood red, that carries oxygen to every cell of your brain, including the cells reading these words, is the final product of stellar nucleosynthesis. Iron is the last element that a massive star can fuse. When a star's core turns entirely to iron, the fusion reaction stops. The star collapses in less than a quarter of a second, rebounds into a supernova, and scatters its iron into space. The iron in your blood was forged in the death scream of a star, and for the elements heavier than iron, gold, platinum, iodine, uranium, those were created in the collision of 2 neutron stars, the densest objects in the universe, short of black holes, smashing together at 1/3 the speed of light. The iodine in your thyroid gland, the gold in whatever jewelry you wear, neutron star collision debris. I want you to hold out your hand. Look at it. That hand is made of atoms that are, on average, billions of years old. Some of those atoms existed before the Earth formed. Some were inside a star. Some survived a supernova. Some traveled across interstellar space as dust for millions of years, on before being drawn into the cloud that became our solar system. Some were part of the ocean before they were part of you. Some will be part of the soil after. You are not in the universe, you are made of it, not metaphorically, physically, chemically, irreducibly. Carl Sagan said, "The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself." He was not being poetic, he was being precise. Now let me tell you about a woman who proved this, and almost didn't get credit for it. Cecilia Payne-Gaposchkin was a British-American astronomer who, in 1925, completed a doctoral thesis. Her thesis demonstrated for the first time that stars are made primarily of hydrogen and helium, not iron, as everyone had assumed. Henry Norris Russell, the most respected astronomer in America at the time, and told her the conclusion was clearly impossible, and pressured her to include a disclaimer calling it erroneous. She did. 4 years later, Russell independently reached the same conclusion, published it, and was widely credited with the discovery. Payne never recanted. She never complained bitterly. She said in her autobiography, "The reward of the young scientist is the emotional thrill of being the first person in the history of the world to see something or to understand something. Not the recognition, the seeing. She had looked at the light from stars and understood what they were made of. That knowledge existed for 4 years in exactly one human mind. The universe knew itself, briefly, through her. The stars that built you lived and died on timescales that make human history look like the blink of an eye. Small stars like our Sun burn for 10 billion years. Massive stars, the ones that produced your heavier elements, live for only a few million years, burning brilliantly and dying violently. Our Sun is about halfway through its life. It has been burning for 4.6 billion years and has approximately 5 billion years remaining. In cosmic terms, it is middle-aged. In the Milky Way galaxy alone, there are an estimated 200 to 400 billion stars. In the observable universe, the portion of the universe whose light has had time to reach us, there are roughly 2 trillion galaxies. The number of stars in the observable universe is approximately 10 to the power of 24, a 1 followed by 24 zeros. That is more stars than there are grains of sand on every beach and desert on Earth. More, in fact, considerably more. And in all that fire and darkness and nuclear fury, the atoms that make up your left hand were assembled. A thesis that the astrophysicist Otto Struve later called, undoubtedly the most brilliant PhD thesis ever written in astronomy. Not by intention, not by design, by the patient, relentless operation of physics across time. The universe is not a craftsman with a blueprint. It is more like an endlessly running forge, not building toward anything, not building for anyone, simply transforming matter into forms of increasing complexity because the laws of physics permit it. And what it has forged, over 13.8 billion years, includes you. But there is something the forge cannot explain. Something that happened roughly 3.8 billion years ago on a small, wet, a geologically active planet in the outer arm of a middling galaxy. Something that changed the nature of what matter could be. Think of the oldest photograph you own. A grandparent, perhaps, black and white, formal, the stiffness of a person who was told not to move. Look at their face and follow the chain backward. If they had not met their partner, if their parents had not survived whatever hardship they survived, if some great-great-grandparent had made a different choice on a different day, the chain that produced you is specific and irrepeatable. Break any single link in any generation, and you are not here. Now extend that chain back 3.8 billion years. To the first single-celled organism that reproduced successfully. Every mutation, every survival, every reproduction in an unbroken line from that first microbe to you. An unbroken chain of events that was never guaranteed, never protected, never inevitable. The probability of your existence, calculated from first principles, is so close to zero that the difference is meaningless. And you are here anyway. Earth formed 4.54 billion years ago from the same cloud of gas and dust that formed the Sun. It was a violent, inhospitable place, constantly bombarded by asteroids, covered in magma, no atmosphere capable of supporting anything we would call life. But Earth had something that most planets do not. It had a sequence of accidents so improbable that if you described them to someone without context, they would think you were making them up. First, Earth sits in what astronomers call the habitable zone, the narrow band of distance from a star where liquid water can exist on a planet's surface. Not too hot, not too cold. This zone is not large. In our solar system, it is roughly the width of the distance between Venus and Mars. Earth happens to sit near the middle of it. Second, Earth has a large moon. This is unusual. The moon is thought to have formed when a Mars-sized body struck the early Earth in a glancing blow, ejecting material that coalesced into our satellite. The moon stabilizes Earth's axial tilt. Without it, Earth's axis would wobble chaotically between 0 and 85 degrees over millions of years, creating climate extremes that would almost certainly prevent complex life from evolving. Mars has no large moon, and its axial tilt has varied by tens of degrees over geological time. Earth has been kept steady. Third, we have Jupiter. The largest planet in our solar system acts as a gravitational shield. Its enormous mass captures or deflects the majority of asteroids and comets that would otherwise bombard the inner planets. Without Jupiter, Earth would be struck by major impactors roughly 1,000 times more frequently than it has been. Life would have had no time to stabilize. Fourth, Earth has plate tectonics. The constant grinding and recycling of the crust regulates the carbon cycle, releasing CO2 through volcanoes when the atmosphere cools too much, absorbing it through mineral weathering when it warms too much. For 4 billion years, this has kept Earth's temperature within a range that permits liquid water. It is the most sophisticated long-term thermostat in the known universe, and it runs on geology. Fifth, Earth has a magnetic field generated by the convection of liquid iron in its core that deflects the solar wind, protecting the atmosphere from being stripped away. Mars lost its magnetic field around 4 billion years ago. Its atmosphere gradually blew off into space. Today, Mars is a radiation-scoured desert where water exists only as ice in the polar caps. Earth still has its shield. Imagine a version of Earth without the moon. The axis wobbles. The seasons become unrecognizable, polar regions sometimes pointing directly at the sun, sometimes entirely away. The climate swings wildly across timescales too short for complex organisms to adapt. Single-celled life might persist in some form, but there is no trilobite, no fish, no amphibian, no reptile, no mammal. There is no flower, there is no tree, there is no you. That version of Earth might be orbiting some other star right now. We don't know. What we know is that our Earth, with its moon, its Jupiter, its magnetic field, its plate tectonics, its unlikely position in the habitable zone, has produced over 4.54 billion years every species that has ever walked, swum, flown, or grown on its surface. And only one of those species has turned its face to the sky and asked where it came from. The Milky Way contains roughly 40 billion Earth-sized planets in the habitable zones of their stars. The observable universe contains 2 trillion galaxies. By some estimates, there should be planets capable of supporting life in unimaginable numbers. And yet, of all the life that has ever existed on Earth, of all the millions of species that have evolved and gone extinct over 3.8 billion years, only one has developed the capacity to study the stars, to ask about its own origins, to build instruments that can detect the light of galaxies that formed 13 billion years ago. Only one. Carl Sagan looked at a photograph taken by the Voyager, one spacecraft from 6 billion kilometers away. A photograph in which the entirety of Earth is a pale dot, smaller than a single pixel, caught in a sunbeam, and wrote, "That's here, that's home, that's us." He continued, "There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment the Earth is where we make our stand. Not a lament, a statement of fact that if you let it, changes everything about what you take for granted. Here is the strangest fact in the history of the universe. For 13.8 billion years, this universe has been operating without a witness. Stars were born and died without observation. Galaxies collided, events of such violence and scale that they release energy equivalent to billions of suns. In perfect, total, unremarked silence. Supernova explosions lit up the darkness for weeks and faded without leaving a record in any mind. The first photons, freed at 380,000 years, traveled across space for billions of years, through a universe that had no concept of beauty, no sense of wonder, no apparatus for experience whatsoever. A river flows. The water doesn't know it's a river. The stone in the riverbed doesn't know it's being worn smooth. The bank doesn't know it's a bank. The entire system operates beautifully, precisely, according to the laws of fluid dynamics and geology, without a single moment of awareness anywhere in it. For 13.8 billion years, the universe was a river with no one watching. And then, approximately 300,000 years ago, in a valley in what is now Africa, a species of primate sat down and looked up. Not because it had to, not to find food, not to avoid predators. The immediate survival calculus did not require looking at stars. But something happened anyway, something that vaults biology into philosophy and physics into poetry. And for the first time in 13.8 billion years, the universe had eyes. Carl Sagan compressed the entire history of the universe into a single year, a cosmic calendar, where January 1st is the Big Bang and December 31st is today. On this calendar, every month represents slightly more than a billion years. In this framework, the Big Bang was January 1st. The Milky Way formed in early March. Our Sun and Solar System appeared on September 1st. The first life on Earth emerged in mid-September. Multicellular life didn't appear until November. The first land plants were December 20th. The dinosaurs arrived on December 25th and were gone by December 30th. And Homo sapiens, our species, us, appeared at 10:24 p.m. on December 31st. All of recorded human history, every empire, every war, every scientific discovery, every piece of music, every painting, every love story, every moment of grief, every child ever born, fits into the last 28 seconds of December 31st. 28 seconds. The pyramids, 22 seconds ago. The birth of Jesus, 13 seconds ago. The invention of the printing press, 4 seconds ago. The moon landing, less than half a second. You, every year you have lived, every decision you have made, every person you have loved, occupy a fraction of those 28 seconds. The first response to this is usually smallness, insignificance, the crushing weight of scale. That response is understandable. It is also wrong. Because here is what happened in those 28 seconds that didn't happen in any of the preceding 13.8 billion years of cosmic time. In those 28 seconds, matter figured out that it existed. The human brain contains approximately 86 billion neurons, roughly the same number as there are stars in the Milky Way. But the neurons are connected to each other. Each neuron forms, on average, 7,000 synaptic connections with other neurons. And the total number of synaptic connections in a human brain is estimated at 100 to 500 trillion. That's more connections than there are stars in 500 Milky Way galaxies. The number of possible states, distinct patterns of neural activation, that a human brain can occupy is a number so large that mathematics struggles to describe it. One estimate, 10 to the power of 10 to the power of 15, a 1 followed by a quadrillion zeros. More possible brain states than there are atoms in the observable universe. And inside that extraordinary apparatus, something arose that has no scientific explanation: consciousness, subjective experience. The feeling of what it is like to be you, specifically, looking out at the world through your particular history and your particular losses and your particular small joys. Richard Feynman, the physicist who received the Nobel Prize for Quantum Electrodynamics, who played bongo drums in Brazilian nightclubs, who worked on the Manhattan Project and spent the rest of his life troubled by it, was once asked whether knowing that a flower is made of cells, and those cells are made of molecules, and those molecules are made of atoms, and atoms are mostly empty space, whether knowing all of that made the flower less beautiful. He said, "I can appreciate the beauty of a flower. At the same time, I see much more about the flower than he does. I could imagine the cells in there, the complicated actions inside, which also have a beauty. I mean, it's not just beauty at this dimension, at 1 centimeter, there's also beauty at smaller dimensions. The fact that the colors in the flower evolved in order to attract insects to pollinate it is interesting. It means that insects can see the color. There's all kinds of interesting questions that come from a knowledge of science which only adds to the excitement and mystery and awe of a flower. It only adds. I don't understand how it subtracts. He was not being modest. He was being accurate. Knowing the mechanism doesn't dissolve the experience, it deepens it. And the mechanism of you, the fact that carbon and oxygen and iron that traveled through stellar depths for billions of years arranged themselves into a structure capable of experiencing love, grief, wonder, and the particular specific ache of a Tuesday morning when everything feels heavier than it should. That mechanism is not a diminishment. It is the most astonishing fact in the known universe. For 13.4 billion years, from the Big Bang to the first hominids, the universe existed without anyone knowing it existed. For 13.4 billion years, matter obeyed physics without anyone asking why. For 13.4 billion years, stars burned and died and scattered their elements without anyone calling it beautiful. And then matter stood upright, tilted its face to the sky and said, "I want to understand this. That is you. That is what you are. Not a small thing in a large universe, a universe that became large enough, complex enough, and old enough to look at itself." The Voyager 1 spacecraft was launched on September 5, 1977. It is the fastest human-made object ever sent into space. It has been traveling continuously for 47 years. It is currently approximately 24 billion kilometers from the Sun. In those 47 years, traveling at 17 kilometers per second, Voyager 1 has covered 0.002 light-years. The nearest star to our Sun, Proxima Centauri, one of the 3 stars in the Alpha Centauri system, is 4.24 light-years away. At Voyager's speed, it would take approximately 80,000 years to reach that star. Let me give you a scale model. If the solar system, Sun to the edge of the Oort cloud, were the size of a football stadium, the nearest star would be 2,500 kilometers away. That is the distance from New York to Dallas. From London to the middle of the Sahara. From here to somewhere so far that you could not drive there in 2 days. And Proxima Centauri is our neighbor. The light you see from it tonight, that faint reddish spark in the southern sky, left it 4.24 years ago. You are seeing the past. You are always seeing the past when you look at the sky. The further the object, the deeper the past. The Andromeda Galaxy, a spiral galaxy similar to our own, the nearest major galaxy, is 2.5 million light-years away. The light reaching your eyes from Andromeda tonight left it 2.5 million years ago. At that time, there were no Homo sapiens on Earth. The species standing on the savannah, looking up at the same galaxy we now see, was Australopithecus, a hominid that walked upright but hadn't yet developed stone tools. The most distant objects we can observe, galaxies seen by the James Webb Space Telescope, emitted the light we are receiving now when the universe was only 300 million years old. And we are looking back 13.5 billion years. Astronomy is not about distance. It is about time. Every telescope is a time machine. The observable universe, the sphere of space whose light has had time to reach us since the Big Bang, is approximately 93 billion light-years in diameter. It contains an estimated 2 trillion galaxies. The number of stars is approximately 10 to the 24th power. And it is almost entirely empty. The average density of matter in the universe is approximately 5 protons per cubic meter. In most of the universe, if you could travel in any direction for 1 million years, you would encounter nothing. Not darkness. Darkness implies space. Just space. Expanding space. Cooling space. We do not know if we are alone in this space. This is not a comfortable uncertainty. In 1950, The physicist Enrico Fermi, one of the architects of the nuclear age, sat at lunch with colleagues and asked a question that has never been satisfactorily answered. If the universe is as old and as vast as it appears to be, and if life has had billions of years to evolve and develop technology elsewhere, why have we detected no signal, no transmission, no artifact, no evidence of any kind that intelligence exists anywhere other than here? We call this the Fermi paradox. Its solutions range from intelligent life is extraordinarily rare to civilizations inevitably destroy themselves before achieving interstellar communication to they are communicating in ways we haven't learned to detect. None of these explanations is comforting. All of them are profound. Imagine standing on a beach at 3 in the morning. No lights. The ocean in front of you, the sky above. And you realize, slowly, that every star you can see is at least 4.24 light-years away. You could shout as loud as you wanted. It would take 4 years for the sound to reach even the nearest one, if sound could travel through space, and any response wouldn't return for 8 years. Now multiply that by a factor of millions. The stars in the visible sky are not 4 light-years away. They are tens, hundreds, thousands of light-years away. The galaxy is 87,000 light-years across. Andromeda is 2.5 million light-years away. That is the silence of the cosmos. Not malevolent, not indifferent in the way a person is indifferent. Simply operating on scales of time and distance, where human concepts like communication and connection and response dissolve into meaninglessness. And yet, on this small, a geologically active planet, circling an ordinary star in the outer arm of a middling galaxy, there are people who reach across that silence every day, not with radio telescopes, with their hands, with their voices, with the act of sitting across from someone they love and saying, "I see you, I know you are here, that matters." In a universe of 10 to the 24th stars and 13.8 billion years of empty time, that exchange, that specific, unrepeatable moment of recognition between two conscious beings, is the rarest thing in the known universe. It is not small because the universe is large. It is extraordinary because the universe is large and mostly empty and silent, and you are not. The universe was born in fire. It will end in cold, not from lack of energy, not from catastrophe, but from thermodynamics, the inexorable tendency of any closed system to move from order toward disorder, from structure toward uniformity, from complexity toward sameness. The universe is running down, slowly, over timescales that reduce the entire history of civilization to a rounding error, but running down. In 1998, 2 independent teams of astronomers studying distant supernovae made a discovery that overturned every existing cosmological model. The universe, they found, was not slowing its expansion, as gravity should have been causing it to do. It was accelerating. Space itself was expanding faster and faster, pushed by something they could not see, could not measure directly, could not explain. They called it dark energy. The discovery won the Nobel Prize in Physics in 2011. As of today, a dark energy accounts for approximately 68.3% of the total mass energy content of the universe. Dark matter, another invisible, unidentified substance that we detect only by its gravitational effects, accounts for another 26.8%. Ordinary matter, every star, every planet, every galaxy, every atom of everything you have ever seen or touched or been, is 4.9%. We live in a universe 95% of whose contents we cannot identify. That is not a failure of science. That is science at its most honest. What follows is the timeline that current physics predicts. In 5 billion years, the Sun will expand into a red giant, engulfing Mercury and Venus, and either swallowing the Earth or scorching it beyond recognition. The Milky Way and Andromeda will be in the process of merging, not in a series of violent collisions, but in a slow gravitational dance lasting hundreds of millions of years, distorting both galaxies beyond recognition before settling into a new elliptical galaxy that astronomers have already named Milkomeda. In 150 billion years, the expansion of the universe will have carried every galaxy outside our local cluster beyond the cosmological horizon, the point from which, due to the accelerating expansion of space, light can no longer reach us. Every galaxy beyond our immediate neighborhood will become permanently invisible. If intelligent life still exists at that point, they will live in a universe that appears to contain only the galaxies of the local group. If they have no records from our era, they will never know the universe is larger than that. The sky will have grown dark, and in 1 to 100 trillion years, star formation ends. The gas clouds that birth new stars will have been depleted. Existing stars will burn out one by one. The massive ones first, over billions of years. The small red dwarfs last, over trillions. Eventually, the last star will exhaust its fuel. It will not explode. It will simply cool. The universe will enter the degenerate era, an age of white dwarfs, neutron stars and black holes, slowly cooling in the dark. No new light, no new energy, just the long, cold dimming. In 10 to the 40th years, if protons decay, a process predicted by some but not all theories of particle physics, not yet observed, the last solid matter will dissolve. The white dwarfs will evaporate. The neutron stars will erode. Everything made of atoms will, at last, cease to be made of atoms. Only black holes will remain. And even they are not permanent. Stephen Hawking predicted in 1974 that black holes slowly radiate energy, what we now call Hawking radiation, and that over extraordinarily long timescales they must eventually evaporate entirely. A black hole the mass of our Sun would take 2 times 10 to the 67th years to evaporate. The supermassive black holes at the centers of galaxies, hundreds of billions of times the mass of the Sun, would take up to 10 to the 100th years. 10 to the 100th years. A Google. After that, the dark era, a universe of photons and leptons, the most fundamental particles, drifting in expanding, cooling space. No structures, no processes, no gradients of energy that could permit work to be done. Heat death. The final state of maximum entropy. The universe at perfect equilibrium. Where no further change is possible because there is no longer any difference between anywhere and anywhere else. Time, in any meaningful sense, will have ended. Freeman Dyson, the physicist who designed the Dyson sphere, who participated in Project Orion, who spent decades at the Institute for Advanced Study thinking about the ultimate fate of intelligence, spent years calculating whether mind could survive the death of the universe. His answer, in a famous 1979 paper titled Time Without End, was perhaps yes. If thought could be slowed sufficiently, if the interval between each computational step could be extended to match the falling temperature of the universe, an intelligence might think an infinite number of thoughts over infinite time, using vanishingly small amounts of energy per thought. Not eternal life in any human sense, but a kind of cosmic stubbornness, thought persisting, not because the universe was hospitable to it, but because it refused to stop. He called it the principle of eternal life. Later work, incorporating dark energy's acceleration, showed that Dyson's scenario was probably not physically possible. The accelerating expansion eventually breaks even the minimal energy budget. But the spirit of the calculation matters. That a physicist sat down and asked, can mind outlast matter? Can consciousness persist after the stars have gone? and that the answer was, we are not sure, but let's find out. That is what we do, even at the edge of the knowable, especially at the edge of the knowable. You are living in the most extraordinary window of cosmic time. Not because you are special, the universe does not issue assessments of specialness, but because the physics only permits this kind of life, this kind of complexity, this kind of consciousness during a specific window. Right now, the universe is still making stars, still making planets, still generating the energy gradients that allow for chemistry, for metabolism, for thought. In 1 trillion years, it will no longer do this. The window will have closed. You exist inside the window. Physics placed you here, and the universe, the vast, cold, expanding, accelerating, dying universe, is producing, at this exact moment, exactly enough warmth and complexity for something like you to sit in the morning light and ask what it means to be alive. There is a moment many people know. It is not scheduled. It does not announce itself. It is the moment you are doing something ordinary. Washing dishes, sitting in a car, walking down a hallway, and you suddenly understand, with a completeness you cannot argue with, that a particular period of your life is over, that the children are grown, that a parent is gone, that the person you were 20 years ago, with all their certainties and their unknowns and their particular way of walking into a room, that person is not coming back, and you sit with this. Not dramatically, not with the operatic grief of youth, with a quieter, more permanent kind of recognition. I am not here to tell you the universe cares about that moment. It doesn't. I am here to tell you that moment, that specific, unrepeatable, unembodied recognition that time has passed and things have changed and you have loved things that are no longer here, is the product of 13.8 billion years of physics arriving finally at sufficient complexity to experience its own passage. The universe cannot feel the passage of time. You can. That is not your limitation. That is your distinction. Physics has a principle called the conservation of information. In the long debate over whether black holes truly destroy information, a debate that Stephen Hawking entered on one side and eventually reversed, the current consensus among theoretical physicists is that information is never truly destroyed. It may be transformed, encoded, scrambled beyond practical recovery. But the record of what happened is never erased from the structure of reality. What this means, in the language of physics, is that every event that has ever occurred, every state the universe has ever been in, is permanently encoded in the history of space-time. It cannot be undone. It cannot be made to not have happened. In that sense, limited, physical, stripped of any metaphysical promise, the day your father taught you something matters, not because the universe recorded it with sentiment, because it happened. It is a point in space-time. It is real in the most irreducible sense that anything is real. The entropy that will consume this universe will scatter the atoms of your body to the distant corners of a dying cosmos. But entropy cannot make that day not have happened. The second law of thermodynamics has no jurisdiction over the past. What has been, permanently, ineradicably. This is not religion, and this is not comfort designed to console. This is physics stating, as precisely as it can, that reality includes not only what is currently happening, but the complete unalterable record of everything that has already happened. Your life is permanently part of what the universe has been. I want to say something about the particular position of being the age you are. There is a version of the cosmic perspective that young people receive, and it is frequently sold as humbling. You are small. Your concerns are small. The universe doesn't care. In the face of all this, what does anything matter? That version is not wrong, but it is incomplete. The complete version is only available after you have lived enough to understand what small actually means in practice, after you have watched enough things end, after you have had enough mornings where the smallness of everything felt like an accusation rather than a liberation. Because the complete version is this: yes, you are small in the spatial sense. A human body is roughly 10 to the negative 10th power of the diameter of the observable universe. The numbers are not disputable, but Jupiter is 1,300 times the volume of Earth. Jupiter does not know it exists. A neutron star is 1.4 times the mass of the Sun compressed into a sphere 20 kilometers across, one of the densest objects in the universe. A neutron star has never asked a question. Scale is not the relevant measurement. The relevant measurement is, of all the matter in this 13.8 billion-year-old universe, how much of it has achieved the capacity for experience, for memory, for loss, for the particular phenomenon of knowing that something was beautiful precisely because it was going to end. We have one confirmed answer, and you are part of it. Richard Feynman was diagnosed with 2 rare forms of cancer in 1986. He died 2 years later, at 69. In his last years, he continued working, continued teaching, continued playing the bongo drums. Colleagues who visited him near the end reported that he seemed improbably at ease. He said in one of his last interviews, "I was born not knowing and have only had a little time to change that here and there. It is not scary not to know things. I have a feeling of satisfaction and feeling that I've done things, and I know what I love. Not resignation, not bravado. The genuine satisfaction of someone who understood the difference between the questions that could be answered and the questions that could only be lived. He spent his career studying the behavior of matter at scales a billion times smaller than atoms. He understood the structure of reality more deeply than almost anyone who had ever lived. And his conclusion at the end was, I knew enough. I loved enough. That is enough. Matter became Feynman. Feynman understood matter. The universe looked at itself through him and found it interesting. Then he stopped. Then matter became something else. You are still here. Same hands, same cup, same light through the same window. But now you know what the hands are made of. You know where the window's glass came from. The silicon in it, forged in stellar interiors, or scattered in ancient supernovae. You know the light streaming through it left the sun 8 minutes ago, and before that was stored in the sun's core for 1,000,000 years, waiting. Everything is the same. Everything is different. That is how physics changes you when you let it. People sometimes use the scale of the universe to make you feel small. That is a misuse. Size is not importance. This is not a sentiment. It is an observation. The observable universe is 93 billion light-years across. It is almost entirely hydrogen and helium and empty space and forces operating without intention. Of all of that, all of it, the portion that has achieved the capacity to ask a question about itself is, as far as we know, a thin smear of biological tissue on one rocky planet in one ordinary solar system. The universe did not build us. We emerged from it unexpectedly, from the bottom up, through processes that had no goal. But here we are. And we are the only part of the universe that knows the universe exists. That asymmetry between the vastness of what exists and the smallness of what experiences does not diminish the experiencer. It makes the experience extraordinary. You are 45, or 50, or 55, or 60 years old. You have lived through enough to have a specific relationship with time, not the abstract relationship of someone who has not yet felt it run out. A real relationship, one with weight. The question of meaning is not a luxury question for you. It is a practical one. Not, what is the meaning of life in the philosophical textbook sense? But, was it worth it? Did it count? Does the fact that it ends make it less real while it was happening? Physics does not have the standing to answer that question. Physics describes the mechanism. It cannot evaluate the experience from inside. But physics can tell you this. The hydrogen in your body is 13.8 billion years old and has been part of stars and planets and oceans and other living things. And now it is part of you, and eventually it will be part of something else. In the long reckoning, nothing is lost, only transformed. The iron in your blood was forged in the death of a star and is currently carrying oxygen to the neurons that are processing these words. The same element, the same iron, moving from stellar furnace to supernova to interstellar cloud to solar system to ocean chemistry to life to you. And inside all of that matter, inside this extraordinary assembly of ancient atoms, there is something that cannot be recycled. Something that does not survive the transformation. Experience. Not information in the physics sense, not data. The felt quality of being alive. What philosophers call qualia. The redness of red, the specific weight of grief, the precise quality of the light in a room where something good has just happened. When the atoms of your body are recycled, they will carry the history of what they were part of. Inscribed in the structure of reality, unreachable but real. But they will not carry the feeling of what it was like to be you. That exists exactly once, in exactly one place, for exactly as long as you are alive. Not because the universe is kind, because the universe is physical. And the physics of consciousness, whatever it is, does not copy and does not replicate and does not transfer. It exists uniquely. There is a constellation that everyone in the northern hemisphere can find. Orion, the hunter. 3 stars in a row for the belt. 4 more for the shoulders and feet. Every person alive today recognizes this shape. Every person who has lived in the northern hemisphere for the last 5,000 years of human history has looked up and seen the same arrangement. The Egyptians saw it. The Greeks saw it. The people who built Stonehenge saw it. The person you loved most, at some point in their life, stood under the same arrangement of lights and looked up. In 100,000 years, Orion will be unrecognizable. The stars will have moved enough in their independent orbits around the galaxy that the pattern will have dissolved. Our descendants, if we have them, if civilization has survived whatever it has to survive, will look at the same section of sky and see a random scatter of stars. But right now, tonight, the same Orion, the same 3 stars in a row, as it has been for every generation in the history of writing and probably many generations before that. Something about that continuity, something about the fact that the sky your great-grandchildren will see on a clear night is, in this detail, the same sky you see, is as close to permanence as the physical world actually offers. The universe is temporary. Everything in it is temporary. But right now, it is arranged in a way that has been consistent for the entire history of human consciousness. And you are one of the last generations that will see it this way. I want to say one more thing. There is a question that the universe cannot answer about itself. It can describe itself through physics, through mathematics, through the elegant machinery of general relativity and quantum mechanics. It can be described from the outside, structurally, mechanically, in equations that work with extraordinary precision. But the universe cannot answer, what is it like to be this? Not because the question is unanswerable, but because answering it requires something the universe cannot generate from physics alone. It requires a subject, an experiencer, an inside. For 13.4 billion years, the universe had no inside. It was all outside, all structure, all mechanism, all process, no perspective. You are the inside. Not you specifically, not one person, but consciousness, subjectivity. The fact that there is something it is like to be you, reading these words in this moment, carrying whatever you are carrying. That is what the universe required 13.8 billion years to produce. That is what 5 billion years of Earth geology was building toward. Not consciously, not intentionally, but structurally, by the logic of increasing complexity. And that is what will end, not the atoms, those will continue, but the specific, once-only experience of being this person, in this life, in this body, in this time. You are made of hydrogen, born in the first 3 minutes of time. You are made of carbon, forged in stars that burned and died before the Earth existed. You are made of iron that was produced in the last moment of a stellar life, or in a supernova no one watched, in a corner of the ancient universe. You carry in your body the entire history of the matter that makes you, a history 13.8 billion years long, recorded in the physics of every atom. And what makes you different from every other arrangement of matter that has ever existed, from every star and planet and comet and cloud of interstellar gas, is not your size, not your complexity, not even your intelligence. It is that you know this. You are the universe's one experiment in self-knowledge, not the only possible one, perhaps not the most sophisticated one in existence, somewhere in those 2 trillion galaxies we can't hear from, but the only confirmed one, the only one we know about, and the experiment is temporary. All experiments are temporary. That is not a tragedy. That is the condition under which everything interesting happens. Not despite the limit. Because of it, the universe does not need you. It existed for 13 billion years before you arrived, and it will continue for trillions of years after you are gone, in forms that will make your era as undetectable as a single breath in the history of all weather. But there is one thing the universe has never been able to do for itself. No matter how large it grows, no matter how long it lasts, no matter what forms of matter it assembles and scatters and reassembles across the depths of time, it cannot look at itself and ask, "What am I?" That. Only you. I have been thinking about what to call what we have been doing for the past hour. It is not exactly science education, though the science is real and the numbers are accurate. It is not philosophy in the academic sense, though the questions are philosophical. It is something closer to what happens when you hand someone a very long lens and say, "Look at yourself through this." The lens is cosmology. What you see through it, that is personal. That has always been personal. Here is what I hope you are left with. Not awe for its own sake. Awe is easy and cheap and dissolves by morning. But a durable reorientation, a shift in the default frame. The default frame for most of us, most of the time, is the human scale. Our bodies, our years, our cities, our century. In this frame, 70 years is a long time. Losing someone feels like losing everything. Getting old feels like running out. The cosmic frame does not invalidate the human scale, yet it contextualizes it. And the context is this. In 13.8 billion years of matter doing what matter does, the particular arrangement of matter that reads, that grieves, that loves, that asks questions about its own existence, that arrangement is so rare, so recent and so temporary, that its very brevity is part of what makes it significant. A mayfly lives for a day. We do not say a mayfly's life is meaningless because it is short. We say, if we say anything at all, that whatever the mayfly experiences in that day is the entirety of what a mayfly's day can contain. Every possible mayfly experience compressed into 24 hours. Not impoverished by its brevity, concentrated by it. You are not a mayfly. You are a creature capable of understanding your own position in the history of the universe. And that position is this. You exist in the brief luminous window when the universe is still warm enough, complex enough, and active enough to produce minds, before the last star goes cold. before the forge goes dark. While the forge is still blazing, the French philosopher Albert Camus wrote, "One must imagine Sisyphus happy." He was writing about a man condemned to roll a boulder up a hill forever, watching it roll back down, beginning again. The absurdity of effort without permanent result. The dignity, Camus argued, was in the continued choosing, in the rolling of the boulder with full awareness of what it was. I am not arguing for absurdism, but I am pointing at the same insight from a different angle. The universe will end. You will end. Everything you have built will, eventually, be reduced to its constituent atoms, and those atoms will eventually be reduced to their constituent particles, and those will drift in an expanding, cooling, darkening cosmos for incomprehensible spans of time. This is not nihilism. This is the view from outside the atmosphere. From here, the question is not whether things end. Of course they end, everything ends, but what happens while they are still happening? What it is like while it is like something, and what it is like while it is like something, is extraordinary. By any measurement, by any comparison, there will come a moment, it might be tonight, it might be years from now, standing somewhere unremarkable, when you look at something ordinary and see it for what it is, not a cup of coffee, a thermal gradient maintained by a manufactured ceramic vessel, filled with a solution produced by a plant that evolved in Ethiopia, heated by energy originally generated in the core of a star 93 million miles away 8 minutes ago, held by hands made of atoms that have been in stars and oceans and other living things for billions of years, tasted by a nervous system that took 3.8 billion years to evolve the capacity for pleasure. Just a cup of coffee. And also a small, temporary, unrepeatable miracle of physics happening at the exact intersection of time and matter, that is you, now alive. Both things are true. Both things held at once are the complete picture. The universe cannot look at itself and ask, "What am I?" That. Only you.